Hello friends, welcome back to our CCNA 200-301 series. Yesterday we finished day 3, so today we are going to discuss in day 4. So let's start. In day 4 we are going to discuss about OSI model. In our networking, OSI model is very important, so today we are going to discuss about OSI. So let's start. OSI stands for Open System Interconnection Model. It is very important. OSI reference model. It is a standard of international organization for OSI reference model is a standard for international organization. It is a general purpose framework that characterizes the standardize how PCs are communicating each other over a network. It is a conceptual model. It is a conceptual model and it has 7 layers. So OSI model is not a real-time model. It is a conceptual model. Means if we want to learn how data are communicating between two PCs, how we are communicating like that, we need to understand OSI model. With that one we can understand other models which we are using in the real world. Okay, so this is only for understanding purpose we have this model. And it has 7 layers. Layer 1, layer 2, layer 3, layer 4 and 6, 7 like this we have 7 layer total layer. It's 7 layer approach to data transmission division, the operation into a specific related group of action at each level. So let's start the layers one by one. First layer is application layer. In this layer we will consider the application like browsing, email, other software. Like all users, whatever application we are using, example if we are using WhatsApp, Facebook, Twitter or Instagram, anything, that is application. So this application layer is responsible for a user to make the communication users between another user. Like in simple words we can say application layer is responsible to make the communication between humans, means human beings. Like I want to communicate with you and you want to communicate with me. We are doing a WhatsApp chat, so we are using application. So application layer is responsible for all application whatever user are using, like browsing or email or any other types of software. Whatever software we are using, application is responsible for that one. And then we have presentation layer. Presentation layer is responsible for presenting the data to the application layer. Example, if I have data in my computer, data is nothing but information. So many things I have in notepad, I have in image, or I have video or audio file, anything I will have. I have so many things. So how I know this is audio file or this is video file or this is word file? That is nothing but presentation. So presentation layer is responsible to present our data. Okay. So in simple words we can say the presentation layer is responsible for data format. Okay. Then we will go for session layer. What is session layer? Session layer is nothing but the layer which is responsible for creating and maintaining the session. You will have doubt what is session like this. Example, I will give you example. If you log into the any net banking site for any net banking, it will be for some time if you are not performing any operation, it will log out automatically. That is, session layer is responsible for creating and maintaining a session. We can say like it is nothing but time frame between the client and server. So did you understand? Session layer is responsible for creating and maintaining the session. An example is net banking. If we log in net banking and if we are not performing any operation, after few minutes it will log out automatically because it is maintaining some session. Then we have transport layer. So now we are going to discuss about transport layer. Transport layer is responsible for delivering of data from source to destination. Okay, like we have any data and we want to transfer from one computer to another computer. So that for that data, transport layer is responsible. Okay. Transport layer use two types of protocol to transmit the data. That is TCP and UDP. TCP and UDP are the two types of protocol we use to transmit data from one point to another point. So that is TCP stands for Transmission Control Protocol and UDP stands for user datagram protocol. Okay, and this one is little slow compared to this one, so I will write this is fast and this is slow, little slow, not that much, because this will take acknowledgement and this will not take any acknowledgement, no acknowledgement. Okay, so TCP stands for transmission control protocol, and it wait for acknowledgement, and this UDP is nothing but user datagram protocol, and it does not wait for acknowledgement, and this is reliable and this is not reliable. Means example, this is example for this one is browsing a website. Like we are browsing a website, if website is not coming, we are sending data same like that until we get the reply. So this protocol send the data till it reply. Example, if I have one computer here, computer PC1, and another computer is here, that is PC2, I am sending something like I am sending here to here hello, and if he is not replying, then again I will say hello. Till he reply, I am saying hello. So when he reply that I receive your hello, I will keep quiet. So that is nothing but TCP protocol. That TCP protocol is working like that. But UDP protocol, he will send hello, and if the PC2 reply or not, he will send another message. How are you? What are you doing? And where are you? He will send. He will not wait for the other guy to reply. He will not think he is listening or not. Just his work is to transmit whatever data he has to transmit. That is nothing but UDP, user datagram protocol. Okay, that's why it is fast. Example, if we make call, like one person is calling to another person, that call is nothing but example for UDP. That type of protocol is nothing but UDP, and the protocol which is using for that one communication. Example, I am doing a video call or audio call, because other guy will not listen even though it is working and it is not doing retransmitting. Example, if I call to one guy and say hello, how are you, and he did not understand that one, he maybe sound is cutting anything, then again I am saying are you able to hear me? He say yeah, now I am able to hear you, but before I cannot. So okay, but this protocol is not sending. If he send that again the old message, he in between it will come hello, how are you, like this. So this is good, right? So this protocol is not sending or not resending. This one is resending the message till he get the acknowledgement, but here he is sending only one time, not sending again and again. Now we will move to next layer, that is network layer. This layer is responsible for adding a source and destination address. Example, if we want to send some data, then we need to have the address, right? Without address we cannot send. So we need to have the source address and destination address. So this network layer is responsible for adding the destination and source IP address. Then we have next data link layer. Data link layer is also responsible for adding a source and destination MAC address. Our laptops is having MAC address, our routers is having MAC address, our switch is having MAC address. All the device whatever we are using, we have MAC address. So that MAC address adding by data link layer. So data link layer is responsible for adding the MAC address. Then we have physical layer. This layer is nothing but like cable, whatever cable we connect, signal, voltage, whatever is going. This is the physical, so we can touch like cable. Last layer is nothing but for RJ45 cable we can say, or optical fiber cable, any cable which is connected or going the signal like zeros and ones and going in the cable like that. Okay, then we will go for TCP IP model. So it is a protocol which consider of multiple protocol including transmission protocol and IP protocol. Okay, and it is a main protocol which nowadays we are using, means in our computer operation today we are using this only. The before the one which we study, the ISO, that is only for understanding purpose we use that one, but this is a protocol which is working in real time, whereas OSI reference model is a conceptual and the TCP IP used for transferring data from the network. Okay, so this one. Now we are going to see what is the TCP and how it look and what are the layer we have. TCP is also having the layer, but not use all layer whatever present in OSI layer. Okay, so let me show you the layer how it look. See, here we have application layer, transport layer, internet layer, network access layer. As we can see, the above three layer in TCP what we have here, let me show. In OSI model we have this three layer. Okay, this from here to here, this three layer. In TCP IP we make this three layer into one layer, and it is known as application layer. And the data, the format whatever is flowing the data is known as data. And again, if we see the transport layer, here also remain transport layer in TCP IP model, and here we will say data as segment. Then network layer is now name changed to internet layer, and the data is nothing but it is in the form of packets. And then data link layer and physical layer changed to become a network access network layer, that is last layer, and it is known as bit frame, the data whatever present here in this one. Okay, so this one we say network access layer, and this is a difference between the OSI model and TCP IP model. So you understand, right, what is OSI model and what is TCP IP model. This is just high level. We are going to bring one more video, maybe after few video, that will have the more detail about each and every layer. This is just high level to understand that one. After that we will discuss the IP address, because I am covering this everything in one video. So next video we can do the lab and practical in our packet tracer. So it is good if you know all this one, then we can start the packet tracer. And we will in next video we are going to discuss about switch and types of switch. After that switch, then we will start router switch, and we are mixing and doing the mix lab for router and switch. Then after that we will do the routing protocol, what are the routing protocol and different types of routing. Okay, so that's why I'm covering all this. Maybe this video become little lengthy, I'm covering this all thing. Okay, so now we are going to discuss about IP address, because this is very important. IP address is nothing but internet protocol. We are having two types of version, that is IP version 4 and IP version 6. Because why we have IP version 6? Because IP version 4 is going to be finished very soon, and already it is finished, but still we are using. But new vendors like new service provider using IP6, and some service provider is using IP6 also. But anyhow, we will learn for both IP version 4 and IP version 6, both we are going to study. Now we will see the IP version 6. Okay, so here IP use packet called IP packet to carry the information. Every IP packet should have the address. So IP address is a 32-bit address, and it consists of two parts, and that two part is nothing but one part is network part, another part is host part. Okay, so see here, IP address is example we are writing, this is 192.168.1.1. generally we are writing like this. So like that we can divide IP address, and it is having four part, 1 2 3 4, and each part is 8 bit, and this is I'm saying network portion, and host portion. We can divide depending upon the class type, we can write that one. This is just example for this one. And here I will say the same thing I am repeating. IP address is 32-bit, and we can write into 4 block. Each block size will be 8-bit. This is the 4 block, 1 2 3 4, and each block size is 8-bit. Okay, and IP address are dividing into 5 classes, 5 types of classes. In 5 types of classes IP address is defined, that is class A, class B, and like that. So who is dividing that is INA is a company who is giving the IP address, that is known as Internet Assigned Number Authority. So this is INA. And class A, class B, class C, class D, class E. And class A IP is nothing but starting IP from 1 to 126 is class A, and from class B is nothing but starting from 128 to 191 is class B, and class C is from 192 to 223 is class C, and class D is 224 to 239, that is used for multicast, and class E is 240 255 till from here to here, and it is reserved for research and all that one. But in our lab and in our CCNA we are going to discuss about this 3 class only. So you need to remember this three class A, class B, class C. Okay, so we are going to use only these three classes. Now we will discuss about subnet mask. Whenever we write the IP address, example I will write 192.168.1.1, we will write subnet mask also. Example, maybe you see in our LAN card, when we are assigning the IP, we are going to write subnet mask also like this. So what is that one and how we will get that one, we are going to see here. And see here, class A is having one network and 3 hosts. Class B is having 2 network and 2 hosts. Okay, and class C is having 3 network and 1 host. Did you understand? We need to remember this one. Class A is having 1 network part and 3 host part. And class B is having 2 network part and 2 host part. Class C is having 3 network part and 1 host part. Okay, and network part is represented with 255 and host part is represented with 0. So same here also. So now you need to remember, for class A subnet mask is 255.0.0.0 and class B is this one and class C is 3 times 255 and last is 0. Okay, then we will see what are the IP type. We have 2 types of IP, that is, one is private IP and one is public IP. Private IP is nothing but a private we can use in our organization. It is free, it is unregistered IP, it is unique within the network, it is not recognized the internet. Means private IP, example, if I want to use internet, I need to purchase the public IP from internet service provider or from INA. But if we don't want to use any internet, only I have example, I have 20 computer and I have using as a lab in my institute. Example, I am having institute, I am having 20 computers. I want to make the communication between these 20 computers. No need for internet anything, just only communication between this computer. So what I will use? I will use private IP because it is free. And same IP we can use in different company also. In my company is using this, your company is using this, both are separate. We can use, no issue, and it is free and it is unregistered IP. And it is not, it will not go to the internet. If we want to use for internet, we need to use NAT, then we can use internet. But for that purpose also we need to have at least one public IP. Okay, so same here I will say public IP is used in the public network and it is not free. We need to pay for to purchase this one to ISP or INA to get this one, and it is registered IP and it is globally unique. Means if I get one public IP, then other guy will not have the same IP because it is globally unique and it recognizes internet. Means with that IP we can go to the any sites or anything, or we can host any website on that IP. Okay, so this is a basic about the IP. And please find the below the private IP. So private IP range, above we see class A, class B, class C IP addresses. Here we see this is a classes IP. Class A means here, B, this all we check here. But here we are saying some are private, some are public, and for private it is free, for public we need to pay, and with private we cannot host any website, but public we can host website. So we need to know what is private range, what is public range, right? So this is a public private range. For class A 10.0.0.0 to 10.255.255.255, and for class B 172.116.0.0 to 172.31.255.255, and for class C 192.168.0.0 to 192.168.255.255. So just you need to remember this range. So whenever we are doing any our lab, so we can pick any IP from here because it is private IP and we can use in our internal organization. Okay, so this is a just basic about networking. What we discuss today, we discuss about OSI model and TCP IP model and difference in between these and what are the function of each layer, and we discuss about types of IP and what is host and how many network part we have in classes, class A, class B, class C, and how many host part we have, and network part represent with 255 and host part represent with 0, and types of private public IP and the range of private IP. So we learn in our today class these 3 topics. So next coming video we are going to discuss about what is switch and different types of switch and how we are going to configure the switch, and what are the modes, same modes we use in router, that's modes, and then a small configuration in switch. After that we are going to start routing protocol, and we are going to see all the detail in the course, our course, that is CCNA 200-301. Daily we are going to upload one video in our YouTube channel and our Facebook page. So try to like our video and subscribe to our channel and share with your friends who are interested in CCNA. And if you are watching our video in the Facebook, try to like our Facebook page. And if you are watching our video in the YouTube, try to subscribe to our channel and hit the bell icon, so you will have the notification when we upload a new video, that is class 5, class 6, day 5, day 6 video very soon. See you. Bye. Thank you very much for watching our video. Bye.